at vector analysis, and in vector analysis we'll be discussing vectors in rectangular coordinate system. So to describe a vector, which is denoted as a with an arrow over it in 3D, we break it down into three parts, one for each dimension. So the dimension, what I mean here is x, y, z. So this is what I mean here. We have our x, y, z. These are the dimension in a rectangular coordinate system. So the components ax, ay, and az, these are the length or magnitude of the vector along each axis. So this is ax, ay, and az. It's just a component along each axis. So let's look at unit vectors. Unit vectors are denoted, let me just write it here. Unit vectors, right? So unit vectors are denoted as a with a little inverted triangle over it, x, a, y, a, z. So these are tiny pointers. These are tiny pointers of length that specify the direction of x, y, z. So what I mean here is that, let's come back to the graph here. What I mean here is that the unit vector is a tiny pointer that specifies direction. So let's say along the y-axis here, let's say the direction is moving out towards the right, then the a with the sign over it, y, is showing the direction. That's what we call the unit vector. Let's have same thing here with a, z, showing the direction of z. So that's what we call the unit vector. It's just a tiny pointer that specifies the direction. So let's look at the equation. The equation a vector is written as the sum of all parts. So a vector, which is written as a with this arrow over it, is written as a x, our unit vector, showing the direction of x, a of x, plus a y, our unit vector again, showing the direction of y, plus a z, our unit vector of z, right? So this is the equation of how a vector should be written as. So now the unit vector is a specialized tool used to describe only direction without worrying about how big the quantity is. Alright, so the magnitude, let's look at magnitude. So the magnitude is written as either just A or A with a little bracket, with our arrow over it in straight bracket. Magnitude represents the total length of the vector. It is calculated using the Pythagorean theory in 3D. Let me show what I'm talking about. Our magnitude A, right, which is calculated in the Pythagorean theory. This formula right here. Sorry about that. Okay. A square x plus A square y plus A square z. So this is the formula to find the magnitude. Alright. So a unit vector. Okay, I can just clean this up. A unit vector A, our sign here, x along a vector is defined as the vector itself divided by its magnitude. So to find a unit vector, we use the formula A equal to our vector divided by the magnitude, which is A. Magnitude could also be written as like this. Same thing for magnitude. So right now we've gotten three formulas. Let me just quickly write our three formulas on the side here. So for our first formula, we have our vector, which is A with the arrow over it equal to AX, our unit vector, plus the length, our unit vector, plus AZ, our unit vector, and then our formula for magnitude, we have it as the magnitude equal to A square of x plus A square y plus A square z. And then our formula for unit vector, we have our unit vector equal to the vector divided by the magnitude, So these are the three formulas we've gotten so far. Right, so let's continue from where we stopped. So let's not keep talking and not discussing why all this matters. Well, in electromagnetics, we often need to know which way a field is pointing. That is the direction, regardless of its strength. A unit vector always has a magnitude of exactly 1. So let's continue with position vector of a point. So this is a very specific type of vector that tells you exactly where a point is located relative to a starting point. That's the origin. Let's say, for instance, we have our rectangular coordinates, and let's say we're looking for an object in space, which is here. So the position vector of a point explains where the object is in space. So the essence of what I've been explaining so far is to translate physical arrow in space into math, math, mathematical equation you can actually solve. So any vector can be split into x, y, z parts. I'm just making point of what we've done so far. Unit vector gives us the direction. Position vectors tells us where something is. So let's solve a problem to understand what we've been learning so far. Let's say we have the example. Let's say suppose you have a point in space. Suppose you have a point in suppose you have a point in space. That's point P. Let's say we have 2, -3, and 6. So our first problem is to find the position vector, the position vector to calculate the magnitude and let's say 3, find the unit vector, find the unit vector. So to find the position vector of this problem, which is written as R with this arrow over it, P, this is X, Y, Z. So let's not forget our formula as I earlier stated. X, our unit vector, plus AY, our unit vector, plus AZ, our unit vector. So we have AX as 2 unit vector plus We have our AY as negative 3, our unit vector, plus we have our AZ as 6, our unit vector. So therefore, this is the answer to our position vectors. So now let's find the magnitude. The magnitude, let's not forget our formulas I earlier stated, which is A equal to x plus a squared y plus a squared z. So our magnitude, which is our ax, which is 2, don't forget the square, plus our ay, which is negative 3 square, plus our az, which is 6 square. So if you do the math here, we should have the square root of 49, which is equal to 7. This is the answer to our magnitude. And now to find the unit vector, to find the unit vector, as I earlier stated, the formula to find the unit vector is the vector divided by its magnitude. So we have our magnitude here as let me just quickly wipe the screen. So earlier we found our unit vector to be we found our velocity to be 2, its unit vector plus negative 3 as we earlier got, plus 6 its unit vector, all over its magnitude, which we got as 7 earlier. So we can rewrite this as our unit vector of A is equal to 2 all over 7 x plus negative, okay, so this becomes negative now, negative 3 all over 7, let's not forget the unit vector here, plus 6 all over 7 its unit vector. So this is the final answer to find our unit vector.